Let us now find out the transformation rule of the metric tensor that we just talked about. So remember, for vectors we got a transformation rule under the Euclidean coordinate change, which is basically the rotation and inversion, as follows. A, if it is a vector, then the transformed form of the vector A prime would be equal to L, where L can be L rotate and L inversion, acting on the same vector in the non-transformed coordinate system. That means the coordinate system before transformation. So now at this stage we have our index notation, and so in terms of indices we can simply write this as AI prime equal to L, and here we write AJ. So that means that for L we'll have to write it as Li for this, formatting this index, and Lj, which is contracted with this index. Let me just put bars on top of these in order to distinguish them from dual vector. So now the question is, what is the transformation property of the dual vector under such sort of coordinate transformation? I should write a prime here. So what should be this operator doing here? And we can do this from the concept of preservation of dot product. That means before and after, the dot product between two vectors should be the same. So that means we have A dot B, and this is nothing but simply the dual of A acting on the vector B, right? So remember that the matrix representation of a vector was needed to be transposed in order to get the matrix representation of the dual vector. So now after a coordinate transformation I get, so from this, after a coordinate transformation we get LA, and we take a transpose of the whole object. This should give us the transformed dual vector in the new coordinate. So I should have got a dual prime should be a dual and then L transposed. So then in the component form we get AI BI, and by our presupposition I should get AI prime BI prime, which is a dual prime acting on B vector. So from this we get, there should be a prime here, we get this is equal to a dual L transposed, and then we get L acting on B vector, but from this we get a dual acting on B vector. So from these we get L transposed L equal to the identity, and that means L transposed is equal to L inverse, which is a very, very crucial relationship for us. Now at this stage, let us verify whether this statement is true. So for example, if we have a three-dimensional vector rotating with respect to the x-axis, then the rotation matrix would be 1 and cosine theta sine theta with negative sign, and sine theta cosine theta. So this would correspond to the representation of L, and L transpose therefore would be 1, 0, 0, 0 cosine theta sine theta, 0 minus sine theta cosine theta, which is indeed representation of L inverse. So that means it's true. You can also try it out for an inversion matrix. For inversion with respect to the x-axis, we get the following representation: -1, 1, 1. And if we transpose this, it stays the same. And if we multiply this with the same matrix, we get identity. So this is the same as L inverse. I think this point is abundantly clear. Now the next step, in component form, we had AI BI being the same as AJ prime BJ prime. So AJ prime would be LJ I and B prime J would be L J K B K. If we substitute them in this expression, we get L J I A I and L J K B K, and then I've got L J I L J K. Notice the contraction here, and then I've got AI B K. So this should be AI B I. So in order to do that, this must be delta I K, because delta I K AI B K would give us AI B I. So that means that L J I L J K equal to delta I K. This is nothing but the component form of L transpose L equal to the identity. Therefore, this is the transformation rule of a vector which we knew from beforehand, but now we have assured ourselves that this is the transformation rule for the dual vectors. Notice that transformation rules like this can be associated solely to the position of the indices. So we will further confer that each contravariant index transforms like this, and each covariant index transforms like this. Therefore, the metric tensor Gij, notice that I've written I and J in order to signify that both of these indices actually indicates special coordinates only. That's just a detail. So this will transform as G prime ij, and this should be transforming as L I M L J N G M N. So this is the transformation rule of the metric tensor. Basically, the transformation rule of the component of the metric tensor, which we wanted to deduce at the very first place, and was the motivation of the video.